Hello everybody, this is Dr. Hoyt. This tutorial will cover classification using RapidMiner, and we'll look at the Turbo Prep option, which does data preparation, as well as Auto Model, which will create a model with several algorithms. The data set we're going to use is a heart disease prediction data set, and the description in the textbook tells you where it came from and also gives you a link to the data dictionary. You'll notice that there are 14 columns. The last one is heart disease, yes or no, predicted on cardiac catheterization. It's important to look at the data dictionary. For example, when you look at sex or gender, 1 is male and 0 is female. You need to understand what some of these designations actually mean before you analyze the data. Let's now look at Turbo Prep. Now to use Turbo Prep, you can go straight to it, but I first had to load the data to a local repository and then open it up. I won't go over those steps, but the video link I gave you will explain you how to load data. Notice at the top you have transform, cleanse, generate, pivot, merge, model charts, and create process. I'll go over each of those briefly. Notice above here you can see the distribution of the data, and to see it in more detail, right click and show details. This is just an example that age is reasonably well distributed. It gives minimum, maximum, average, and standard deviation. Let's look at cholesterol. Notice that there are outliers here, so even though this looks somewhat well distributed, there are in fact outliers. For more information, you can access the little instructional icon where they explain data, including there's a data preparation video that's very useful. We'll be talking about the fact that it rates the quality of the data, and that's listed here of how it does it. Here are the 5 quality measures that it automatically determines for your data set. Now let's talk about transform first. This allows you to rename, for instance, and let's go in and rename. Let's select a column and let's rename it gender. And I'll put apply, and I want to keep that, so I'll commit the transformation, so now it's gender. But there are other things that you could do with transform. You can, again, let's just click on a column. You can rename, which we've already done. You can remove it. You can change the type of data. You can copy it. You can filter it to certain numbers, let's say, or range. You can sample the data, and you can sort it ascending or descending. Let's go to cleanse. Notice auto cleansing, which we'll get to in just a minute. You can remove low quality columns if they exist, or remove correlated columns, which is important because there's no point of having 2 columns that basically give you the same information. You can also, let's go ahead and pick cholesterol. Up comes also normalization and discretization, PCA, which is principal component analysis, and remove duplicates. We'll demonstrate normalization in just a second. Discretization just means that you can create bins or bags of data. For instance, under age, you could create decades of age if you needed that for analysis. Let's look at auto cleansing, which is interesting. Let's select first the column that we're trying to not include in it. Click Next, We'll keep the original next, and we're going to perform normalization. When you do this is when your columns contain data with different scales. Let's say some are 100 to 1,000, others are 0 to 1. This will do it for you, and we'll go ahead and apply this. And what you see here is the data standards. The scales are all similar. I'm not going to include that. I'm going to cancel out of that. The same would be true of PCA, and rather than do it, let me just explain that it uses unsupervised learning, and instead of having 13 predictive variables of the outcome, heart disease, yes or no, it'll condense it to just 4. The generate allows you to do several things. You can add a new column, which may come in handy, but you can also add a formula, such as add or subtract. You can do a log of a column, square root, and so forth. So you can, in other words, sort of like Excel, you can modify the variables as you see fit. Pivot table allows you to regroup the data for analysis. Let's give an example of that. Let's drag gender to this right here, and the number of vessels to the bottom. And so the average, though, by gender, this is male, female, is different. The male clearly has a higher number or percent, and let's look at it this fashion by hitting this icon. So there appears to be quite a bit of difference, but it does not include a statistical analysis to know if it's statistically significant, but it's certainly interesting. So let's cancel out of that. Merge simply allows you to combine 2 data sets, which could be very useful and would mean that you would not have to do a SQL query to combine them. Let's go to charts. There are actually 33 choices when you click the down button here that you can use. We're going to select box plot. And for the value column, we're going to select blood pressure. Let me get rid of gender for blood pressure. Group by heart disease. So go over here and group by heart disease. So here is the box plot showing you that the blood pressure with and without heart disease looks similar. However, the range is greater for those people with heart disease. In other words, there's more people with elevated blood pressure than in people without heart disease. You can mouse over the box plot to get the quartiles and other information from that. So you can select a variety of charts to suit your purpose here. The create process just shows you workflow. And I'm not going to actually go over that, but you can look at how the model is set up, the operators that are present in the workflow in the process, but we won't cover that. Instead, we'll go over other things. You look at the 3-dot ellipsis here. You can export this data set. You can rename it, copy, or remove it. Let's go to the Model tab. Notice you have a help section on the right. We're going to load the same data set, and it's in front of you. We're going to select predict, and then the column of interest, of course, would be heart disease, yes or no. Select next. The class of highest interest is clearly the presence of heart disease. We'll click next again. Here is the different algorithms we're going to use, and we're going to reduce the number by unclicking several. We're going to use naive Bayes, logistic regression, deep learning, and decision tree. Let's go ahead and run those. And it may take a minute to see it. On the right, you see the run times, and on the left, you can see other information populating. And I want to show you that the drop-down menu here gives you a variety of endpoints. Accuracy, classification error, area under the curve, precision, recall, F measure, sensitivity, and specificity. Recall is the same thing as sensitivity. Precision is the same thing as positive predictive value. F measure is just one more measure of performance. We can see here, though, the accuracy was highest for naive Bayes. Let's look at area under the curve. 0.941 is also the highest. So we'll look at also several other. Here is the receiver operator for all of them to compare, and once again the naive Bayes was the highest. Let's go down and look at weights by correlation. Overall, looking at all the models, thallium was the most heaviest weight, followed by the number of vessels that were calcified on fluoroscopy. And then if you want correlation between these, you could look at thallium seems to correlate the highest. If you look for the highest number, appears to be with gender at 0.391. Let's look at the decision tree by clicking the arrow next to it. Let's look at the model. This gives you the ability to look at how the decision tree approached it using thallium score greater or less than 4.5 is how it divided it up, and you can see that here the presence of heart disease over there, and where the majority had absence over here, and you can see what it's split on. ST depression over here, maximal heart rate over here. And let's go back to the naive Bayes, since it was the best performer. This is a density diagram, and you can look at different things, such as let's look at maximal heart rate. There is some separation. So you can see that maximal heart rate between those people that had heart disease and those people who did not appears to be different. You can look at the weights, and in this model, the maximal heart rate carried more weight. A simulator, let's look at several things here. Using this model, this is how it rated the factors for the absence of heart disease, meaning What supported absence was the maximal heart rate. Those people without heart disease had a higher maximal heart rate on treadmill testing than those with heart disease. The simulator means it's a slider. You can adjust these variables and see how it affects your model. Performance, this is basically a confusion matrix, and you can predict true positives and false positives from it. Again, these are the different determinations. You could click sensitivity, 91.6, specificity of 89%. Here's the F measure. So that's very, very valuable. A lift chart is another way of looking at performance for a classification, a binary classification like this, and is similar to the receiver operator. And here is predictions for patient number 1. For instance, it predicted presence of heart disease, and in fact the person had heart disease, so you can go into each individual patient and determine how your model performed. Further details are available on the RapidMiner site and tutorials.